At WFM Labs, our organization recognizes the importance of gaining market insights to compete effectively and provide better goods and services to our customers. However, exchanging price or commercially sensitive information with competitors can violate antitrust laws and harm competition. To avoid antitrust risk, it is essential to ensure that information exchanges in the WFM Labs community are reasonable and promote competition. This includes avoiding discussions or coordination of sensitive topics such as customer prices, pricing paid to vendors, compensation paid to employees, or proprietary information. If you would like more information, please refer to the guidelines outlined by the FTC and DOJ, Antitrust Guidelines for Collaborations Among Competitors. In addition, WFM Labs meetings are being recorded. By continuing to be in the meeting, you are consenting to be recorded. And finally, we ask that all participants review and comply with our code of conduct. Thank you.
All right, good evening, everybody. So this evening we're going to talk about Monte Carlo simulation and start to talk about a risk rating system. I'm going to spend a few minutes just with an introduction to Monte Carlo simulation. In episode 10, I went over that. I'm not going to go real deep into the what's about Monte Carlo simulation, but just touch on it. And then Dave and myself are going to demonstrate two Monte Carlo models that we built. And then to close out, we're going to open the door on this concept of risk rating capacity plans. Not something that's done too often in contact centers, but we'd like to start the conversation there and bridge into our June session where we really do want to get the community dialed in and giving us feedback on best methods for applying a risk rating system. I'm going to spend a few minutes and then I'm just going to open it up to our audience here to participate. If you're new to WFM Labs, which nobody on this call is new to, but if you're watching this and you're new, we're a group of people who have come together, workforce management professionals, customer service professionals, really looking to start thinking about the next generation approach to not just workforce management, but how we're operating contact centers as a whole. There's an awful lot of change going on right now between AI, automation, simulation, and we think it's time that we step back and re-examine the model that we've used for the last 20 or 30 years. If you're, again, watching the video or you're new to the organization, this is our third session. We started these evening sessions 2 months ago on March, where we talked about a new maturity model for workforce management. It's recorded, it's available out there to anyone as part of our community. Ping anyone online here if you'd like to know how to find that. We then last month talked about the high cost of attrition, spent some time with a dynamic calculator. And this month we wanted to pivot and start talking about this notion of Monte Carlo simulation and starting to apply risk ratings to our capacity plans. As I mentioned in episode 10, I gave an introduction. You know, Monte Carlo simulation involves inputs that have uncertainty. At the simplest level, you've got models where you have inputs that have uncertainty. Very important element of it is assigning probability distributions. And again, without going into too much detail, the Monte Carlo approach basically runs many iterations of those variables that have uncertainty against a probability distribution. We're not going to get into a big statistics class, but this is an important thing if you want to start to understand how to apply Monte Carlo simulation, is to understand that there are different probability distributions associated with our data. If you're not into statistics, you probably want to tap on someone's shoulder to tap into knowledge around what the best probability models are to use to build a Monte Carlo simulation. We're going to show some simple things tonight here, but this is a a piece of the whole equation that you just don't want to gloss over. You really do want to understand, and we have the data to understand what is that appropriate distribution to apply. The benefits are ultimately we can come out with better decision making by using these models. We're going to talk about risk assessments, but introducing the language of risk into our capacity plans is an important element of it. At the end, we should be able to deliver options, provide greater flexibility toward our capacity plans rather than being pushed into a corner where we've got what I term as a fragile capacity plan. As I mentioned, if you are new to Monte Carlo simulation, this isn't really where we're going to go over the details of it. However, as Dave and I demo things, we absolutely can have a dialogue, questions, and double click into things. But again, there's a ton of resources out there. I just did a brief overview of what Monte Carlo simulation's about in episode 10. I also referenced a course by MIT that I think is pretty valuable in terms of learning more about it. And then again, between YouTube and the internet, you can go deep, deep, deep into understanding what this methodology is. So we're not going to basically spend time going over that. What we really want to do tonight is kind of dig in and say, how can we apply this to our model or to our business, to our domain of expertise? In constructing a Monte Carlo model, you really do have to define like a problem, define the problem and objectives that you want to go off after and simulate. You then need to identify the variables and their relationships, and then you go ahead and build the simulation model. In our particular case, we're picking capacity plans as sort of the problem. And again, we've talked about this in previous sessions. Capacity plans quite often are built with fixed point inputs. We come around to budget season, we say, hey, next year we're going to take 1.98 million calls. We're going to have a 445-second handle time, 32% shrink, 85% occupancy. We have all these inputs, and then we run our math and we come up with an output. And that output is also a fixed point. And that's what really ultimately creates this fragility that I speak to. We all know when we build our budgets that while we're taking a best shot at a number or maybe an average, we know there's variation. And, we know at the end of the year, we're not going to end up with exactly 1.98 million calls. We know that handle time might average 445, but there's variation. And that's where the simulation comes into play, is it allows us to start to take these variables and look at a range of inputs. Instead of a fixed number of 445 seconds, we say, there's variation here. We've got uncertainty. It might be between 440 and 465 seconds. And then we assign in Monte Carlo simulation a probability distribution to those inputs. And then we essentially run thousands of iterations of what the model looks like based on that probability distribution. We don't do it just with one variable, but we do it with as many as we want to simulate a range. Maybe you know exactly how many calls you're going to get and you put in a fixed variable, but all of us know we don't know. So there's a range of call volume, there's a range of handle time, there's a range of shrinkage, a range of occupancy, a range of attrition. We none of us know exactly what that value is going to be, but we do have a sense from our own data of what sort of ranges we might expect. And with that range of inputs, we can simulate a range of outputs and ultimately look at something that says, well, instead of 248 head count, I may need as few as 230, 220, as many as 280. And the real power behind Monte Carlo simulation is it allows us to assign those probability ranges and ultimately to say, with a certain degree of confidence, a head count of 270 is going to cover X percentage of scenarios. At the end, this is where the power comes in and where we feel like it's time to introduce this model. So I'm going to pause there. Everybody's on mute. Dave, Jim, or anyone who's got questions, if you want to add anything to this before we pivot some, the next section of this presentation is really going to be, we want to roll up our sleeves, and Dave, I'm going to ask you to start first, and then I'm going to follow, but we're going to give you a kind of a real world example. Both of us have built a couple of models here that we want to share with the community. But before we go into that, any questions or any other comments around how Monte Carlo simulation comes into play in our world? All right, so as I mentioned, we're going to go through two of them. Dave McCutcheon has built a model that I'm going to have him share, and I'm going to have him take over. We'll flip over screens and make sure, Dave, that you're comfortable bringing up and sharing your model that you built. Dave's model doesn't have any plugins, I don't believe. Dave, you can keep me honest here, but I think you wrote this straight off of an Excel spreadsheet where we've got inputs, and I'll let him demo, his model. And then I'll go over to my model where I do leverage a input into, well, it's an add-on, it's a plugin, whatever you want to call it, a plugin into Excel that allows me to capture the simulations, and I'll share that with you in a moment. So
you all tell me.
I think we see you.
All right. So I was being unusually quiet when you said if anybody has any comments or thoughts, because I was going to let you all talk before I get handed the mic. So yeah, I'm going to run through Excel. Seems to be everybody in workforce, it's their favorite friend, and I love to build stuff in Excel, and then we can, it's not as fancy as the sliders and the cool things that Ted has, but it will do the job, and it'll help you sort of understand how to think about it. So I think the most important thing about this, coming back to what Ted was saying, this is an example of one. This is a way to start thinking about it. This is not a model that you can just take and go, all right, now I'm going to capacity plan like this. It needs a lot more thought and build out, but it's the starting point to sort of leap off and leap into this type of analysis. It will certainly get you from, I'm calling it the static or the fragile, and I'll get into some of the numbers in a minute, traditional way of coming up with an FTE requirement, and then we start to get into sort of the ranges. The million-dollar question always in this is, well, what should I use? Like, I don't know what to use, so like, what should I use? And that's going to be probably the first place you're going to want to start. You're going to want to think about it. But I'll just quickly orientate you with this. It's relatively simple. It does exactly what Ted said. It allows us to plug in whatever in terms of, it can be daily, weekly, monthly, interval, doesn't really matter as long as you line up your hours, etc. You can plug in your, say you're doing 10,000 calls a day, 660 seconds, shrink time, occupancy, so on and so forth. 275 in this example, right? So this could be any of your call centers. If anybody wants to use different numbers, throw them out now. It doesn't really matter. Ultimately, this is what we would traditionally, as a workforce team, this is what we would traditionally say, cool, right, let's get budgeted for that. Let's go find that amount of headcount. Let's train and get them skilled up to that. And we're going to go get 275 people. And we're going to hit service level, and because we're definitely going to get 10,000 calls, and we'll definitely be a 660-second handle time. As Ted said, that's complete nonsense, and that never ever happens. What I find really interesting about this type of stuff, and this will be very unique to your different organizations, and even within your organizations, your different queues. Some of you may have relatively stable forecasts, pretty good, pretty tight. Some of you may have really wide ranges. You may be subject to external factors that could, if you think about a daily forecast, maybe you've got mailings that go out. Maybe the weather causes the mailings to be off, and now suddenly your daily stuff is off. Or maybe there's another weather event somewhere that causes people to not get stuff or be able to call. Or there's many examples that we can think of. So you have to think about this in terms of your own business. What might cause that variation? And do I understand it? And do I have the data to look at it? I'm going to give you examples of sort of random data that I brought in to show how this works. But for now, don't even look at the chart. It's incredibly boring. Down here, it's incredibly boring because this is an incredibly boring forecast. because that's what we do today, 275 FTE. So how do we start thinking about this a little differently? And the key to this, and I know that we're going to do a second session on this where we start talking about risk, so I intentionally removed some of the risk factors out of this. So when Ted threw the view up earlier, you could see some red, green, and yellow, and that was just one way to start thinking about risk. I think we'll save that conversation for another time. But we got to understand how this works. So really, I'll give you a couple of examples how we might begin to think about this. And you could think about your own business as well. There's no reason why you can't add other metrics and changes and variables that you want to put into play here. For now, and for the sake of time, I'm just going to focus on volume and handle time, and I'm going to assume everything else is perfect. Again, the reality is probably not, but for now we're going to focus on these two. Want to have at least, more than one variable here. So I've got 10,000 calls. What do I do? How do I know what my range is? What should I use? What's the probability that I won't hit 10,000 calls? So one of the ways that you can do this, and one of the ways that I sort of recommend you do it, it's possibly one of the simpler ways to look at your data. Take your variance over a time period, interval, daily, whatever, and just plot it on a box and whisker, right? So all this does is basically plot each of these different variables for volume. And what this tells you is here's my spread, here's my distribution of all the calls. So, okay, is that good or bad? And still, what should I use? Like I was saying earlier, that might be good, that might be awesome for your business, that might be the best you can do. That might be pretty bad, and you might be having a conversation with your forecasting team about making it tighter, but maybe not. Maybe your operation works like that. So the way to look at this and the way to think about this, so for anybody that's not aware, the way that this data is basically being presented, it's being presented in quartiles, and then the box and whisker basically says anything that we would consider to be outliers would be outside of these whiskers. So that's your 12 and 17. In the case of this example, you really wouldn't use them. You can if you want to, but I wouldn't recommend it. You may not even use the minus 22 and the 11, and we'll come back to how that works in a minute. The area in the middle is your second and third quartile, so that's 50% of your values fell into this range. So you might want to use that, right? A minus 10, and in this case, a minus 1, minus 10 to minus 1, upper and lower limit. So we'll plug that in and we'll see what happens. And let's just do the whole range, because why not? This one's pretty interesting. So a minus 22 and an 11. So I'm going to put my upper range. I'm going to put my lower range. You'll notice this never changed, because it wouldn't, because this is how we do things. So we never factor this in. What I want to draw your attention to now, as we start to get deeper into it, is what happened down here. The way that this one is built, this one is, rather than using probability and saying the likelihood of it being 3% over is 10% or whatever, it's literally just doing a random. So it's randomly distributing this. So if you have a very variable business and there's a lot of randomness that can hit you, then you might do it this way. It is a little bit simpler. So in the case of this one, you all know how to do math, so you all could have done this without any kind of fancy model. You could just have said, well, if I need 11, if I need to increase by 11%, then I can do the math. That times 11%, 305. And then going the other way, 215, because it's one variable right now. So far, pretty simple. So far, so simple. Next one. So same way at looking at this. And please stop me and jump in as we go through this, right? I want to make this interactive. You can even throw out some of your own numbers if you want, or if you want to see different views, throw them out. I have a few different versions of this that I will show you in a minute. But for this one, this is the handle time spread. We've got a -9 and a 6. Or maybe we're really going to lean heavy in and we're going to start to tighten this up. So I'm just going to use the -4 and the 0 for now. Again, there's not really necessarily a right or wrong. If I use the -9 to the 6, then I'm capturing 100% of the variance that I got in this data set. If I use the -4 to the 0, I'm capturing 50% of it. Make sense? Going to wait to see if people nod or. Yep. Okay, so -4 and 0. We'll just use that for this one. 0's already there. So now we've factored in handle time. So now what you're kind of seeing, again, you can kind of ignore this chart. The important thing is down here. So what that did, just two metrics that we changed. What we're basically saying in this situation, and it ran about 30,000 iterations of this. It really doesn't matter if you run 30,000 or 10,000 or even 1,000. generally will come pretty close anyway from a distribution perspective. What you're now saying is, well, we could possibly, maybe, instead of needing 275 in the ranges of our distribution that we have here, and based on this forecast, instead of needing 275, we might be able to hit our service with 206. It's highly unlikely, but it's possible because it's the bottom end of your distribution. Or we might want to be, we're really worried about missing service level, and cost doesn't matter. We don't care. We're going to spend all the money we need to protect service level. In that case, we would not run a 275. We would want to have 305 FTE, and that's what you staff up to. That would account for 100% of these possible situations. What that means, however, is with 305 versus a need of 275, you're going to have 100% of the possible, variables that you might come up against where you are either hitting or, in all likelihood, significantly exceeding your service level. But you're not going to miss, in theory, based on that distribution. So what's interesting about this, especially when you don't have balanced upper and lower ranges or equal distribution, you'll notice here, and this is the thing I find the most interesting. So again, in this real world situation, we're doing workforce, we go get 275. 275 happens to land just down here within this range. So by default, we're already accounting for over 70% of the possible variance that we might come across with this range of variance that we have in our forecasts. I'm going to stop. Everybody tracking so far? Good, simple enough. Yep. So what, right? Well, okay, you went and got 275. I've covered 70% of the situations. There's still a situation where you may miss service level. How many times do you get the question from operations or leaders? Why did we miss service level? Or, hey, why are we delivering so far over service level? Well, if you staffed at 275, your answer is it could be any of these numbers, and that's kind of why. This also presents an opportunity potentially. Can you tighten this up? That's quite the range, right? A 48% spread from the top to the bottom here. If you were to tighten this up, to be able to run like this, now you've got a 12% spread. So I used a pretty rough data set that was a lot of variables, but now suddenly we're starting to tighten up. But again, what it allows you to do is sort of assess, like, okay, in this situation, I'm still coincidentally going to have 70%. Now, can I go sell that to finance, right? Are the finance team going to pay the extra or not? And this is why, kind of going back to the maturity curve, really, when we talk about Monte Carlo simulations, we talk about fragile capacity plans, we talk about actually beginning to implement something like this. What you need to understand in your business is, where can I be in this range? In other words, can I staff here and get down to here? Can I staff here and get down to here without having cost or impacts? Can I staff here and at the drop of a hat get all the way up here? Maybe you've got that much flexibility. I doubt any of you have that type of flexibility if we run, what was it, something like this. I doubt any of you can do that much of a spread. We certainly can't where I work. So, but it introduces a way to start having a more kind of thoughtful conversation around, like, what do we need to staff to here? If the business is like, we're going to take a bit more of a risk and we actually want to run potentially a little bit lower, we've still got a 30% likelihood that we're going to hit service level, then we're going to run the 267, which is lower. So all this really is doing down here, this is giving you more data points to allow you to have a smarter conversation with your finance teams, with your operation teams, to say, always traditionally we would have done 275. We would never have thought about it. We would have called it good, 275. But in reality, based on your data and the way that your data is kind of distributed out, you now have a range, and you also have an understanding of what percentage, if 302 is the one you land on, and you go with 302, then, like I said, 70% of the time you're most likely going to hit service level or exceed it. So that's where you can introduce the element of risk. If I just do not want to take a risk on my service level, then I'll go higher up to these numbers. If I'm more financially focused and I'm okay to take that risk and I'm willing to make that bet, I'm going to come down this way. But I'm certainly not going to do that number. So stopping for a minute, because it's relatively quick. There's a lot of like financial stuff here. The financial stuff is just based on if you were to, if we wanted to go from that static requirement up to the higher number and protect service level, then all it's doing is telling you how much more it would cost. That's an annualized cost, of course. So if you want to be a hero to finance and come back and say, I've got $1 million for you, your service team might not like it, operations might be mad at you a few times, but you got $1 million here that you could potentially 10% of the time you're still going to hit service level. That's probably not acceptable in most call centers, but at least you will understand that and you will be able to have that type of conversation. So I'm gonna pause. Simple enough stuff. Any questions, thoughts? It's not so easy to implement, and it's not an easy conversation to have with your teams, but it's sort of thought-provoking, and that's what we're meant to do here. We have not cracked this as far as having conversations with our operations team, with our finance team. In fact, we haven't brought it to them yet, but we're gonna. So if anybody has a question on how do you implement this, don't ask because I haven't figured it out yet, but I'm gonna. So maybe we have a follow-up question in a few months.
No, I think that's a great suggestion too, and I'd be interested, if either on the live call tonight or anyone who's watching this, if you want to chime in after we post it, if you've implemented it before, broken through the door and had that conversation with finance, with executives to start to articulate, hey, 283 will cover 50% of the scenarios, while 311 headcount will cover 80% of the scenarios. Love to hear how that conversation went, because I do think for the majority of us, this is uncharted water. Anyone on the call have experience with it, or just feedback in general or questions?
I think I want to go watch Braveheart now, just as a side note. And it was surprisingly coherent and cogent, David. So congratulations.
It is surprising.
No, it was great. I do think you struck the point, and I think I had mentioned this on a call earlier this week, Ted, is that's where I think we're going to struggle. I think it's kind of like introducing the electric car, right? Where's the infrastructure? Where's the early adopters? How do you make this work in the big picture, right? Somebody's going to have to take some sort of a leap, right? And we talk a lot about industry standards, right? Stuff that's just been the way we do business for 20, 30 years or more. So I do think that's going to be the challenge. Especially when we start getting into statistical models. I feel like that's where, how do you bridge that gap between, that's really great theoretical statistical calculations, and I know you can put it on paper and show me that it's money, but how do we turn it into something that the boardroom's gonna look at and go, okay, that makes sense, and I'm willing to roll the dice on it?
Yeah, I think the reality, even in this view, Jim, and that's sort of where I was going, it's probably not very viable that you're going to be able to easily get between these numbers, right? So remember, as we talked about the maturity curve, this type of sort of planning and thought process was like level 4 workforce. Most of us are still down in level 2. The step in between is a lot of the automation. It's going to be very difficult, even with the automation. The automation is going to help you do some of this, right? For sure. But you still have to have that model, and so it might drive us to think. I constantly having conversations with operations like, how do we get the most flexible staffing model possible?
Well, and just there's one other component to this that I actually had a conversation with someone about today. Is how do you, let's say you hit this mark, how do you translate it down to more of the interval? So, and Ted, I don't know if you'd be able to touch on that, but the example is, I was working with a peer and they were talking about, hey, I get my staffing, my capacity right. I've got the whatever 500 humans I need, and each month I can sort of closely hit my servicing. However, within the month, it's a complete disaster. Right. So, is that a really just solely a scheduling process? Is there anything within this process or these simulations that can translate down? And the reason I think that's relevant to this conversation is that, again, if you get the buy-in, and you get the folks to go, I'm going to commit that additional staff. If you don't have that second piece, now do I get the right people in the right place at the right time? And it turns into a situation where they're barely cutting it, or first half is horrible, second half is full of idle. They're still not going to feel like there was any win here, right? And that's where I think some of the potential resistance comes from, is the first time somebody rolls the dice and they don't get that scheduling right, they're going to go, well, that didn't work at all.
Yeah,
right.
it's a good point. So one of the things about this view, and then I think it will be the same with Ted's, frankly, is this is one data point right now. So then what you've got to think about, and this is where it gets infinitely more complex, but I'll build it next week if you like, Jim. You don't just have one, like you wouldn't just have one required, like, you know, this is sort of the calculation. You'd have it for every single one that you're trying to do. So maybe you look at it at a daily level initially, right? And you might say, well, on a Monday, my range of variability is whatever it is. And then on a Tuesday and so on. So like you would look at each part and you look at each piece that you're trying to forecast and have your range for. It gets very, very complex, but that's how you build it, and that's what you would do. The idea behind this kind of view here is this is one sort of data point, but you're going to do that for like all of it. Ultimately, that's how you bring this thing to life. And then, you know, because there might be some intervals that you're always over for some reason, and then some that you're under, and they may begin to cancel each other out a little bit. But it's a very complicated conversation to have, and frankly, I haven't figured out how I'm going to do it. That's why I was kind of joking, like, ask me in a few months if I manage to crack this one. This conversation right now is relatively simple, I think, but turning this into something, to your point, Jim, that the business can get behind, that they're willing to make the bet on, and like right now, if this is just random numbers, right, or you know, this isn't anything real, but if I was trying to convince the business, I don't want to do this 275. I want you to go up to 302. I want you to spend the extra $1 million because that'll cover us for 70% of the possible situations. But I'm going to make sure that I find a way to sort of, in the situations where we're down here, I'm going to be able to pull it back down and save some of that $1 million. I'm not just going to set up at the 302 the whole time. That's the tricky.
Right.
Yeah. And how do you...
I think it comes down to, I mean, this is the place to start the conversation relative to budget. But if you go to the other end of the extreme and you go down to interval, a lot of this comes back to many of us planning to net zero. It's like we've leveraged our WFM tools to essentially have exactly 68 people on the phone at 11:30. Now, there's some organizations that build overhead, but most of the software packages, other than absenteeism overhead, don't build in variable or a variance overhead down to that interval level. So there becomes a question of, do we want staff to net zero going forward? And I think the answer is, if you can sell it at a capacity level for budget to have the proper overhead. And again, you've got a combination of the technology, because I don't see how you do it without automation. You got to be able to pull those resources off when variation swings in your favor, but then pull the resources back on. It comes down to, are we wanting to staff to net zero, or do we build the appropriate overhead? You can translate this, just as Dave said, you know, from an annual all the way down to an interval. Are you going to want a Monte Carlo simulation every interval? No, but you are going to have a framework to say, well, we do want to cover 70% of the scenarios, and we do realize that that is essentially buffer, but we've got to have a capability to then take it out if we're going to build it in. You know, and that's where I do think it's a combination of automation technology, but then also, to what Dave mentioned, you've got to have your policies, your scheduling, flexibility in your scheduling at a level where you do have the ability to pull those levers.
Right.
Yeah, just a couple more thoughts on that. So occupancy is kind of playing the proxy role for our schedule efficiency in this particular model. And I like where Dave was going around, you know, if we plan for 70% of the outcomes, then we also need to understand what we can do to get down to the point where, you know, we only need 267 people on that day instead of 302. And Ted, you bring up a good point. Automation can help with that quite a bit, but even without automation, we should be able to understand what kind of daily flexibility that we're able to achieve with our current set of practices, and then start pushing on those edges to understand where we can get, so that if we go to finance and say we want to cover 70% of instances, that we have proof that we can actually pull down to the point where we need to. We can pull down 7% on a day with short notice. And I think also, going back to something else that Dave mentioned earlier and going to finance, this is a bit of a back test in a way. So being able to demonstrate that this is how we have actually performed, I think, is a good thing for everyone to understand. This isn't necessarily just simulations in a spreadsheet. This is based on actual performance and where our ranges truly are.
Right there with you on all those statements.
I don't want to take all the time because I know, Ted, you're going to get into kind of a more probability-based one. Again, this one was random. And like, I kind of talked through this with some of my team. I'm like, there's a lot of randomness in some of the things that happen to our business, and we really don't know at times when things are going to hit. And so that's why I felt like, yes, you can definitely use the different distributions with probability. And there's value in doing that for sure, but which one do you pick? And then sometimes randomness actually, just as long as you know your range, that's okay. So yeah, this is going to be super interesting, and like, as people go down this path, I'd love to hear how it plays out. I'm not going to talk about this, like we'll have this for the next session, I think, but I began to sort of think about, like, well, how would I assign a risk to this, and what might that look like, and how would we talk to the business a little bit more deeper about this? So we'll not touch on that today. But it really, again, it will come down to your specific organizations, and even within your organizations, the cues on how are they really protective of service level, or are they just like, it's okay, we'd rather have the money and we'll take a bit more of a risk. So all very different flavors. So if there are any more thoughts or questions on this before we jump into Ted's one. It's relatively simple. I think we're going to put this up. You can use it. I think we're going to put it on the WFM lab somewhere. It's not got anything. You can change everything that's in here. We might build it out a little bit more, so it's a little bit more sophisticated, but it's just an Excel-based model. You can play around with it. You can go and get your own data and put in whatever you want. This was random, so it's quite a spread. But maybe that's just how your organization works. You could have that big a distribution. Like I said, you may not want to do the full 100% minus 22 to 11. You might want to come in the middle somewhere. That in itself is a level of risk. And you have to understand that if you're doing that, you're only accounting for half of the situations. And so you still have inherent risk by doing that. But again, there's no perfect answer to which one you should use. You just have to think about it, right, in terms of what makes sense for your business. So
yeah. That's great, Dave. Appreciate you sharing it, and I'm glad you just flashed up there the risk element of it. We're going to bridge that into the June conversation. Much of what I'm going to share now is very similar to what Dave built. However, it goes into a plugin. So anyone who's watching this, if you want to reach out to actually get this model, I'm happy to share it with you as well. The only caveat to it is that I am using a commercial plugin to run this particular model. So if I gave you the spreadsheet and you don't have the plugin itself, it's not going to be very useful. But it will give you some context around how far you can go with this. At the end of the day, where Dave focused on two variables of call volume and handle time, I've essentially taken, other than work hours, I'm saying I'm pretty confident there's going to be 2,032 work hours in my model, but I'm essentially taking call volume, handle time, shrinkage, occupancy, and then I'm also modeling out my attrition. I even model out how long are my training classes? What's my training attrition look like? There's variation in speed to proficiency. You can get as fancy as saying maybe it's 9 months speed to proficiency, but it could be as low as 75%, as high as 110% of that. Same thing with salaries, with onboarding costs. Essentially, my model right here, if you drive all this down, will give you a head count, and then I'm pricing it out from a budget standpoint. But within the model that I'm looking at here, I've assigned low and high ranges to that particular variable. And then over here, I'm simulating what those costs would be. In this particular model, if I just hit F9, it will continually re-simulate, one after another. On this particular simulation, it's saying, okay, 1.2 million, 1.227 million in 604 seconds, 30% shrink. The next simulation goes down, and it's essentially recalculating at the end of the day my head count and my budget based on these high and low ranges. Now, rather than random, I have assigned a PERT distribution in here. And again, this isn't going to be statistics class. You can Google PERT and figure out it has an emphasis on how it puts the distribution itself. But essentially, there's a whole series of distributions that I could select from when I'm building this particular model. Could be a Bernoulli distribution. I could say we hire people at either 49,000 or at 51,000. So I could essentially construct this model and say, well, there's some percentage of people who are going to be hired at $49,000 a year, some percentage at 51,000. So with these plugins, you have a wide range of distributions, statistical distributions that you can apply to your data, but without going down that rabbit hole, essentially what Dave demonstrated, which is just looking at the spread, is really the safest place to start. Then if you want to become more advanced, apply a statistical model if the data fits. But again, this isn't a statistics class, so we're not going to get into data fitting and what makes sense relative to that. You can start out random, you can look at your spreads. This could be just a random selection based on the spread that I put in here. And essentially with this plugin, you see up here this thing called Model Risk. The plugin is by a company called Vose. And I would just hit this start button, and then it would run, 1,000, 5,000, 10,000 samples in the background. Instead of me running it, I've already run it just because it takes a minute or two. So after I got done running it, I would pull it up, and you would end up seeing essentially the plugin's software to show you a distribution of, and in this particular case, I'm looking at my total FTE. And this is similar to what Dave's chart showed you. Is at the end, you end up with this plot that says, well, I've got a 50-50 shot that I'm going to need 224 head count, for this particular model itself. But what I've also put out here is, just as Dave described, if I had 237 head count, I would know that I'm covering 90% of those scenarios. What's useful for this particular type of a chart is it allows you to go into many more views on how that data manifested itself. The simplest, and I'll show one other one right here, is if instead of head count, I simply wanted to look at my budget. If I flip back to my spreadsheet, you'll notice down here I was talking about an $11 million budget based on this $50,000 higher range. Well, the nice thing here is it says, yeah, 11.2 million is my budget at the mean, but an 11.9 or almost a $12 million budget covers 90% of the scenarios themselves. So this is essentially taking what Dave had described as 0, 10, 20, 30, each of the percentiles, and describing, you can see it over here, it goes 1, 5, 15, 25, what my budget would be to cover those particular scenarios. And I'll just pause there and see if anybody has any questions, and then I'm going to show you one more chart type if I can find it. I thought it had run. in the background. But any questions on what I'm showing so far here?
Ted, yeah, one quick question. So it's using the ranges. Is it assigning equal probability to all values within the range, or is there, these aren't the proper statistical terms, but is it kind of using a mean?
Yeah,
Using a median in the way that it's looking at each variable?
yeah, really your answer, Mark, comes right back to this equation that I end up calculating when I do this number. This is where it's telling me, which of these distributions do I really want to apply to this particular value itself? And as I said, I just, for simplicity, just like Dave used a random distribution, I use something called a PERT distribution, which has this type of probability range that puts on.
Mhm.
And you again, I'm not going to pretend to be a statistician, but you can look at PERT and how it emphasizes. Again, I don't even want to quote it because I'll misquote it, but it has a certain statistical emphasis closer to the mean where it puts more of a value on that. Again, if you had a normal distribution, if you use an Erlang distribution, this Pearson distribution puts a heavier one that skews to the left. So it really comes down to looking at your data, fitting it back to that distribution, and then essentially the model will leverage each of those distributions. Like the simplest one I can use is this Bernoulli. I didn't use that over here. I used, again, a PERT distribution that essentially said 98% is my low range, 105 is my high range. And then really it's just using that PERT distribution to apply the outcomes 5,000 times against 98 being my low, 105. That's the best example I could say where, well, maybe it isn't just a range. Maybe we hire people at distinct values. We hire 20% of the people at 49,000, another 20% at 49.5. And so it's that type of information that you would know either from your data or from your policies that would determine, how you wrote the model here. And then ultimately this should be a reflection of all those variables working with the associated probability distribution to give you this range itself.
Makes sense. Thank you for that.
Sure. I was going to show this tornado graph, which I thought was like a real interesting element of it. The tornado chart itself shows you the sensitivity of each of the input variables. So these input variables down here, and then at the end of the day, let me change this from base FTE to total FTE. If you remember back here, we said 200 and, oops, sorry, that's budget. Let's go to total FTEs. We said about 224 headcount would be at the mean on this distribution. If we had 237 headcount, that would cover 90% of the outcomes. The tornado chart shows you, when you've got your mean value down here in the middle, what is the sensitivity of each of my inputs to that range itself? This can be very useful, and again, is something that is difficult. I'm sure it's possible to get out of what Dave is building in terms of a raw spreadsheet, but here the simulation tool itself is understanding how does shrinkage affect my high and low range. And in this particular case, shrinkage is one of the most powerful levers in the model itself, followed by annual call volume, occupancy, tenure. We see things like the handle time on day one and its range, or my training length, has a much more narrow focus on whether or not I'll need 223 heads or 226. So this is another part of Monte Carlo simulation that's pretty powerful, is to go back and validate your assumptions and then be able to articulate, how these variable inputs are impacting my outcome at the end of the day. It's a good way for us to test ourselves, this range of shrink values and whether or not shrink really needs to be tightened up. Do we need to go back and double click on the data itself? And you'll see these variables change, based on my range itself. If I had a real narrow range on call volume, obviously that wouldn't have nearly the impact that it does if I have a range that goes from 98% to 110%. So you can get pretty fancy with these Monte Carlo models themselves. I won't go into the other graphs, but there is a ton of data that is captured and maintained to allow you to go back then and sort of test, your inputs, your ranges, and your logic behind it. I think Dave's really is the place to start, but this kind of gives you a sense of if you advance up the curve in maturity on building these, and you really want to double click and explore into the data and be able to pivot real quickly to articulate, well, this is what my budget looks like, versus what my, total FTEs look like in the terms of distribution. One final thing, and it's outside of the scope here, but I just want to highlight it in terms of you can also build scenarios. In this particular case, I actually ran 3 different simulations, and in each of the simulations I said I wanted to understand what annual attrition would look like if I basically didn't have any automation, if I had some training automation, and if I had coaching and training. So essentially, instead of 50%, I reran each of these simulations with 40% and with 35% as the plug-in here. And then when I go over to the model, I can go and compare and say, well, if I had partial automation or full automation, this is what my distribution would look like if I swapped those numbers out. So there's an awful lot of power where I can go and say, hey, instead of 215 or instead of 228 headcount, I would need at the 50 percentile mark a 215 headcount. So you can do a lot of different scenario simulations based on, these inputs. You don't have to just stick with 50% as my attrition. I can rerun the model at 40% and at 35% and capture all that data at the same time. Of course, I could go back and manually just plug in a new number, but think about the power if you essentially said, well, my boss is going to come back and say, I don't like 50%, I'm thinking 45% is the number. Well, right there, I now can re-articulate, 45% on my attrition now means that 228 headcount would cover 90% of the scenarios. So that's really rapid in terms of trying to describe that, but I just wanted to give kind of the other end of the spectrum. Where you can start with this should be simple and should be, in what Dave started to share here. But you can take these models. I wanted to demonstrate the other end of the spectrum and really show you can simulate across a whole series of variables to ultimately give you a more informed capacity plan. Let me pause one more time there for any questions, and then I'm going to kind of transition us into what we're intending to speak about next. But any questions? Too complex? Makes sense?
Yeah, it absolutely makes sense. I think, again, that baby step first, working with, no offense, Dave, your model, and then moving. The other thing is, if and when you're able to get more complex, I would say, that's where you got to learn how to run all that and download it and input it right. Like all of a sudden you're becoming an expert. I think that's where, as a group, maybe we look at where tutorials, where and how do we make some of that type of data or tools accessible so that people don't need to go out and get a second degree to learn how to kind of operate some of that stuff.
Yep.
Because it's powerful, but obviously, Ted, that's a lot of work there that you put into that.
Yeah, it's powerful. I think I agree completely, Jim. We need to start somewhere, and in order to get comfortable with this, you don't dive in and put in a Vose plugin. You need to really take your steps through here. Although I will also say you'll get to a point pretty quickly. I think you'll get to that point quicker than you think you do, Once you start to get a comfort level behind the Monte Carlo process, the second comfort level is that range, how Dave demonstrated the range of inputs and whether or not you want to apply statistics to it. Once you've got this, you're going to want more. And
Right.
what I was demonstrating here is there is a path that will allow you to build these types of models. I don't want to say you can do it in an hour, but it took me about a weekend to really kind of dive in and learn this VOS plugin to be able to build this. So it's well within, I think, the ability for many of our people who work on our teams, work with data, work with these tools. But I wholeheartedly agree. You know, you need to start somewhere, and that's why we wanted to kind of compare two ends with Dave's model here as a good starting spot, and then where can you go with it? So you end up with these ranges, just to wrap it back. And where we want to talk in June is, I believe, to make this a more meaningful conversation, rather than saying to your leader or to finance that 270 headcount will cover 85% of the scenarios. I believe a more powerful way to communicate this is by assigning a risk framework to it. This is an area where we'd like to get the community's feedback. You know, do you call 270 headcount and 85% of scenarios an A? You know, do we call, 232 and 15% an F? I will say that translating risk into a rating system of some sort is in my mind going to be a more useful way to communicate with leaders. Leaders do not like ranges, do not like uncertainty, but if we turn the conversation into how much risk appetite do you have, and recognize that when you sign up for a C rated plan, that it's a 50-50 shot, as to whether or not we're going to cover service level on any given month. I think leaders can understand that, and it's a new vocabulary that we'd like to chew on. But we really would like to get input from the community on that, and that's why we said we'd break this session down to two, and really we'll recap quickly next month, if 7 p.m. still works for folks, or if we want to do this during the day, and really like to start to solicit feedback from the community. If you're watching this video, that's the ask for the June session. Digest what we've shared, and then we're looking for ideas around how to assign a risk framework to those ranges. I'll leave it at that and see if there's any closing questions, comments, anything. We're at the top of the hour, so I want to be respectful of people's time, but also happy to take any questions or any closing comments on the session.
I wanted to add one more thing real fast, just to get you thinking, right? So to Ted's point here, and because I don't know if I necessarily made that clear when I was talking about on my one. So really fast, right? So if you go with a 248 in this scenario, you've got a 50-50 shot of making it, or do you? Because the other piece that you need to think about when you think about the level of risk in it is, can I go up by 5 more headcount at the drop of a hat? In which case, I'm going to plan, I'm going to staff, and I'm going to go for the 248. But if I go up by 5 headcount, does that get me to 60% of the scenarios covered? In which case, so that's what I was kind of talking about earlier. When you think about your spread, do you have the flexibility? Do you understand the flexibility? How much can you go up or down? Because that might determine where you want to make your starting point and where you want to make your bet. So just adding that.
No, and you said it well, and I think it's a part of what we've got to wrap into the conversation is what is your inherent flexibility? If you've got a vendor standing by with just resources to throw on the phone at the drop of a dime, well, then 248 might not be a C, because you may have the capability to go pick up a phone and all of a sudden generate 30 headcount on the fly. And I think that's the exact type of thing that needs to be thought through in order for us to come up with the proper framework to assign risk. So spot on, Dave. I appreciate the comment. Any others? Nate, anything from you?
No, this is fantastic. Great job, Dave, on what you put together there. I can't wait to play around with that. But yeah, this I think the risk rating part of it is key, because I think that really helps the conversation, because nobody wants to sign up for an F.
Right. Yeah.
know?
Yeah. If you could go back and go, hey, you signed up for an F. I love it. Yeah,
Exactly.
that's a great one.
Yeah.
Yeah.
So I
Is
think
that your
I think it will,
signature?
yeah, it'll definitely make the conversation easier in my mind.
Yeah. Well, Nate and I had on episode 11 a chat about this. Nate and I have spent 15 years living through bad budgets. And, Nate, you brought up we've kept 2 sets of books in the past,
Yep.
but nobody wants to hear about our second set of books. However, I still think we can stamp a letter grade on a plan and iterate the fact that either we've got the right type of flexibility to flex up and flex down, or we don't. And hence, how do we translate that into language that's meaningful to people? So thank you.
Good stuff.
All
Thanks
right.
to both of
All
you
right.
for pulling it
Nope.
together.
Thank you, community. If you're watching this, again, feel free to leave comments. We're looking for a little bit wider participation in June, and are going to try to more heavily promote that, because we really want to hear from the community on your ideas around this risk rated system. The Monte Carlo thing, I think we can all pick up and start working with it. It's pretty straightforward, but creating a framework for the risk rating, I think will take a community in your input. So I appreciate everyone's time this evening. Thank you. Thanks, Dave.
Thanks, guys.
Thanks, everyone else.
Bye.
All right. Bye-bye.